In this lesson, I will explain to you confidence intervals for the mean when sigma is unknown. In the last lesson, we have discussed sigma is known. In this lesson, we will discuss sigma is unknown. So first of all, I will explain these lines to you. Then I will give you some example to show you how we will find out confidence interval when sigma is unknown. So the value of sigma, and what is sigma? Sigma is the standard deviations of population. When it is unknown, must be estimated by using S. If sigma is not given, then we will use S in our formula. So what is S? S is the standard deviation of sample. The standard deviation of a sample we will use. So simple. And when S is used, now the question is when S is used, especially when the sample size is small or less than 30. So in our case, when sigma is unknown, usually we take sample size which is less than 30. So this is also called student T distribution or only T distribution because we use T table. T distribution table. Now the question arises why we say student T distribution or only T distribution, because it was found by William Shelley Gossett. He was working in Ireland, and in his company publicly research was not allowed by using personal name. That is why he gave the name T distribution or student T distribution. Here I have made some comparison when sigma is known, our last lesson, and here is sigma is unknown. When sigma is known, usually we use sample size greater than 30. If sigma is unknown, we take n is less than 30. And if sigma is unknown, we use t distribution, while if sigma is known, we use z distribution. So this is the difference between z distribution or t distribution, or simply you can say when sigma is known or sigma is unknown. Right, here I have written some characteristics of the t distribution. T distribution is similar to standard normal distribution in these ways, right? We had discussed many times standard normal distribution. Here I am going to show you one more time. So this is our normal distribution, right? In normal distribution, the mean, median, and mode lies at the center. It means same amount of data we have on the left hand side, same amount of data approximately we have on the right hand side. This is the normal distribution. So the characteristics between T distribution and Z distribution which are similar, the first is it is bell shaped. So this is bell shaped, and keep in mind that both these lines you can extend in either direction, but it will never touch to this baseline or x-axis. It is symmetric about the mean, median, and mode are equal to 0 and are located at the center of the distribution. The curve never touches the x-axis. So these 4 points are normal distribution. Also same, these 4 points applies to the T distributions. These 4 points are similar between T distribution and the normal distribution. Right, so the important point is that the mean, median, mode lies at the center. Same amount of data on both sides, and the curve never touches the x-axis. Now there are few points. The T distribution differs from the standard normal distributions in the following ways, and these are the points, right? I will explain to you all this point. The first one is the variance is greater than 1. The second is that T distribution is actually a family of curve based on the concept of degrees of freedom, which is related to sample size. So this point is one of the most important point, and I have to explain what is the meaning of it. It says that T distribution is actually a family of curve, right? So first thing is family of curves. What is the meaning of this? In our normal distribution, see, we make only one curve like this, and here is suppose is our x-axis. But in T distribution, we make many curves like this, like this. So it is called the family of curves, right? But I will show you how we have to make these curves. But simple is, it is a family of curve. It means it has more than one curve, and these curves are based on the concept of degrees of freedom. This is the second point. Now, what is degrees of freedom? And degrees of freedom, which is related to the sample size, right? You know, sample size. Suppose in t distribution usually we take less than 30. Suppose if I take the sample 10, I have 100 students in my class and I pick randomly 10 students out of 100. So this is my sample, right? So degrees of freedom is represented by df. D dot f means degrees of freedom, which is equal to, the formula is n minus 1. And what is n? N is the sample size. So in this case, my sample size are 10 students minus 1. So my degree of freedom is 9. Though my sample size is 10, but my degrees of freedom is 9, right? So what is the meaning of 9 degrees of freedom out of 10? It means if I have 10 numbers, any 10 numbers, the total of 10 numbers are 100. Maybe one is 12, right? Maybe other is 10, or maybe whatever, right? Or we will make it, suppose here one more 10, we are going to make 10. 10, 10, these are 5 numbers. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. So these are 48, 58, 68, 78, 88, and so. Okay, so these are my 9 numbers out of 10. So these 9 numbers are free. Whatever the value they can have, maybe this is 2, 4, this will be 20, or this will be 30, whatever. 9 numbers are free. The 10th number should be a specific number in order to make it 100, right? So these are total 92. So the 10th number is 8. So this is called the degrees of freedom. N minus 1 means 9 number. If I will say my sample size is 5, so if I will ask you what is the degrees of freedom, you have to say 5 minus 1, which is equal to 4. So 4 numbers are free. If I will say the total of my 5 numbers are 40, right? So whatever number you have, suppose we have 8, here 8, and here suppose 10, and here suppose 10. So, and the 5th number should be a specific number in order to make the total 40. That is why it says degrees of freedom, which is related to sample size. I think now it will be clear. So the second property, which is different from the z distribution, has 3 parts. First one is the t distribution has a family of curves. So you know now that we can make 2 or 3 or 4 different curves, but these curves depend on degrees of freedom, and degrees of freedom is related to sample size. And the third is, as the sample size increases, the t distribution approaches the normal distribution. Now what is the meaning of it? I will show you here. See here, this is suppose my normal distribution. If my degree of freedom is 4 in this case, so see here, you have to make graph like this. It means our normal, this is our normal distribution. Normal distribution is greater than t distribution, right? Okay, now my, suppose in this case, second case, my degrees of freedom is 9. So how we will make our graph? It will be on the top of, see here, this is normal distribution. This point is when our degrees of freedom is 9. This graph is when our degrees of freedom is 4. So as the degrees of freedom increases, our t distribution approaches to normal distribution. So this is the third point I have mentioned here. When we will solve the question, this will be more clear to you. So degrees of freedom, here I said the degrees of freedom will be used for degrees of freedom. Same thing I have made here. This is the z curve, which is our normal distribution. Here my t for t distribution degrees of freedom is 18 and this is 4. As the degrees of freedom increases, see this is blue is 18, this is 4. If I will move here, suppose 20, 30, whatever, degrees of freedom increases, our curve approaches to normal distribution. Right? Same thing I have written here. The formula is n minus 1. And for some statistical tests, the degrees of freedom are not equal to n minus 1. But for t distribution, we will use n minus 1. Right? Okay. Degrees of freedom. Here I have written the example that values in calculation of a statistic that are free to vary, degrees of freedom free to vary. What is the meaning of it? Same thing what I had explained now. Suppose a mean of 6 number is 9. We have 6 number and the mean is 9. Right? So degrees of freedom is n minus 1. We have 6 number, 6 minus 1, which is equal to 5. So 5 numbers are free to vary whatever number they can have, but sixth number should be a specific value to get the sum 54, then we can have 9 average. Right, so here I have made some example and this is the another graph. Same thing, this is the normal distribution, this is the t distribution when the degrees of freedom is 20. Here degrees of freedom, this green line is 10. So I have written some notes here. When the degrees of freedom is greater than 30, it may fall between two table. Now what is the meaning of this? See here, you will see when we will see the table. Here is 1, 2, 3, 4, so on. After 30, if we will take our sample 35, 40 or 45, whatever. If it is greater than 30, it may fall between two values. So here I said 60, right? Okay. Suppose my degrees of freedom is, I said 58. So if I will ask you what is the sample size, so sample size is 59 because 59 minus 1, which is equal to 58. So in table, how you have to see, we do not have 58 here. So 55 and 60, it means 58 is between these two. So in some books you can see that they say, okay, we have to use the next, we will round up. In some books they will say round down, which is the conservative approach. Here I am going to use the conservative approach. So if your value is, your degrees of freedom is 56, 57, 58, 59, 59, you have to see this value of 55. Right? If it is between 60 to 80, 61, 62, 63, even 79, you have to see this value. This is the conservative approach, you have to round down. So same thing is written here. When the degrees of freedom is greater than 30, it may fall between two tables. Right, 58, it falls between 55 and 60, but we have to see 55. At the bottom of the table where df means degrees of freedom is large or infinity, as the degrees of freedom, see after 120 we have infinity. It means as the degrees of freedom increases, our t distribution is equal to the normal distribution, and normal distribution you have to see the z table, z distribution. At the bottom of the table where df is larger or infinity, then z sub alpha by values can be used for the specific confidence intervals. As the degrees of freedom increases, the t distribution approaches the standard normal distribution. Right, here I have written one example for you. Suppose if the degrees of freedom is 19, it means our sample size is 20. How you will see this table? T distribution table has two parts. If you will see, the first column is the degrees of freedom, right? And this part here you will see 90%, 95%, 99 and 99.9% your confidence. And then see here, if I will say degrees of freedom, degrees of freedom is 19. Where is this one? 19. And then you have to see
confidence interval, it is 95%. So you have to see 95, which is equal to 2.09 something, 93, right? So if suppose it is given that sample size is 25, please do not see 25 here. Always you have to subtract 1, 24. So you have to see degrees of freedom 24, and whatever confidence level is given, you have to see. The formula for calculation of the confidence interval of the mean when sigma is unknown, this formula. In the last case, when sigma was known, we were using the formula. This is the mean. Instead of this t sub alpha by 2, we were using z sub alpha by 2. Instead of this s, we were using sigma over square root of n less than, and here same thing. So this is the exact formula. Sometimes in different books you can see x mean plus minus and then this part. What is the meaning of plus minus? See here, exact thing I have written with the positive sign, here with the negative sign. Otherwise it both are fine. So when sigma is known, instead of this f you have to use sigma, because sigma is given, then you have to use z sub alpha by 2. If it is not given, then standard deviation of sample, and here we have to use the t distribution. So degrees of freedom are n minus 1. Alpha is the level of significance, right? Whatever is given, we have to subtract 1. If it is 95%, 1 minus 0.95, and then we have to divide it by 2, right? Because it is on both sides, critical region. This is again the table which I will show you how to see it again one more time. Here is my example, a random sample of 10 kids, 10 children. So see, this is our sample size. So when we will see the table, please do not see 10. Here we are going to use n minus 1 degrees of freedom. So 10 minus 1, 9. In table we will see 9, that their average growth for the first year was 9.8 inches. So this is the average. Average is the mean. Assume the variable is normally distributed and the sample standard deviation is 0.96. It's also given. Just we have to put these values in the formula. So 9.8, right? S is 0.96. Sample size you have to use 10. But for t sub alpha by 2, we will use degrees of freedom 9. 9 and what percent? 95%. So I will show you here, it will be more clear. So 9 is here, right? And then 95%. If you will see, different books have different tables. 2.263, sometimes it go to the 3 levels after decimal. So I have used 3 points, 2.262. Just put the values, everything is given, and simplify it. When we will simplify, keep in mind whatever is in the parenthesis you have to solve first. So 0.96 divided by square root of 10, which is approximately 3 point something, then you have to multiply with this and then subtract. So we will get this range. What is the meaning of this range? See, I said here that the average, right? Average growth for the first year is 9.8 inches. This is based on my sample size of 10 kids. On the basis of sample size, we said the population mean is also same. I am 95% confident that the population mean is also 9.8, but 5% maybe I am wrong, right? So the curve is like this. 95%, 95% is the acceptance region, that we accept that population mean is also 9.8 inches, but 5% we are doubt. So 5% means 0.0251 one direction, and here on here maybe it will be a little bit more, or maybe it will be little bit less. So see here, less and greater. So when we find out the range, it is, the answer is 9.112, 9.112, 10.49. This is the range. 95% confident. If I will say I am 99% confident that the growth of the first year is 9.8 inches, if I increase my confidence level, then I have to increase this width as well. Maybe I will say 8.5 to 12. Right, so therefore one can be 95% confident that population mean of the first year growth is between 9.1 inches to 10.49 inches. I hope this is clear. Here I have made one more example. If the degrees of freedom is 21 and you are 95% confident, how you will see the table? So 21 here and 95, so you have to use this value in the formula. Okay, now I have made another question for you only to show you what is the difference between the last question and this question. The data represent a sample of number of homes fire started by candles for the past several years. 99 confidence level is given 99% and nothing is given. So you have to find out x, what is the standard deviation, right? What is the sample size? So do not worry because these amounts are given, figures are given. On the basis of this, we will say 1, 2, 3, 4, 5, 6, 7. It means 7 is our sample size. And degrees of freedom. Now, what is the degrees of freedom? Degrees of freedom is 6. 7 minus 1, which is equal to 6. And we have calculated so many times mean. Just add all these values and divide it by 7. You will get the mean. And after getting mean, you know how to find out the standard deviation. We had discussed this one, right? So you have to subtract each value from the mean, square it, right? And then sixth step we had discussed so many times, and then divided by number of observation, take the square root, you will get the standard deviation. When you have all these values, then only you have to put the values in the formula. So here I have calculated, see this, find the mean. So the mean of all these values are 7041. If you want, you can calculate and double check. And standard deviation is 1610.3. Right? So in the table, confidence level is 99% and degrees of freedom is 6. When you will see, you will get 3.707. And then put these values in the formula. So at the end you will find out, see, 99% we were confident, but there was only 1% doubt, so the range is 4785 to 9297. Because we are 99% confidence, that's why this range should be wider. So here I have written the explanation as well. I hope this question is also clear. So here I have made a very simple chart. Is sigma is known? If it is known, you say yes. Then you have to use z sub alpha by 2 and sigma in the formula. If it is no, if sigma is unknown, then you have, this is alpha, then you have to use t sub alpha by 2 and s in the formula. Otherwise both are same. So here you can pause your video and you can solve. This is the practice problem. Data is given. You have to find out your x bar, standard deviation, sample, degrees of freedom, and only see this is given. Solve it, put the values in the formula, then your answer is also here. You can tally your answer. After this is the practice problem. Here I say if sample size is 18, 99% confidence, then you have to see what value we have to put in the formula. Why I have written this? Because please do not use n is equal to 18. You have to subtract minus 1, which is equal to 17. You have to see 17 and 99% in t distribution table. Same thing here. When you will solve it, then you can tally your answers. Right? I hope this is clear how to calculate confidence interval if sigma is unknown. If you have any question, please ask me. Subscribe to my channel and thanks for watching.